Okay, let's go. So welcome to my talk on Java agents versus eBPF, a pretty special topic, I admit. So it's about deep diving into these different technologies that are both available in the OpenTelemetry ecosystem and that you can use for instrumenting your applications. So a few words about me. I am Fabian. I am engineering manager at Grafana. I've been a software developer for a long time. At Grafana, I'm manager for Alloy, which is our distribution of the OpenTelemetry collector, and for Beyla, which is basically the OpenTelemetry eBPF instrumentation tool. And I also contributed to the Java agent as well. So what are we going to do in this talk? So I'm going to show you a quick demo application on Kubernetes, and we're going to instrument it. First, I'm going to give you a quick introduction how Java agents work and how to instrument stuff with Java agents. Then I'm going to give you a quick introduction to eBPF, and then we will walk through some differences that are hopefully a bit unexpected and interesting. And then, of course, we come to a conclusion. So what should I do now? What should I use? And so forth. Okay? But yeah, let's start with this demo. So I got a slide here, but maybe best I just show it. It's running on a local Kubernetes cluster on my laptop. And it is, so if you are expecting a child, that might be useful. So it's a child name recommendation service. So you can say whatever, I am Spanish, I'm expecting a girl, please recommend a child name. And then it says whatever, you could name your girl Juana or something, right? So just a stupid, demo. In my cluster, I have a web front end, which we just looked at, which is not Java, written in Go, written in Node in that case, right? And then there is the actual backend that generates these name recommendations. And yeah, it's basically REST requests to this URL here, /name, /language, /gender. And then depending on the parameters here, it recommends a name. And of course, most of this talk, we will focus on how to instrument this Java service. Now, the question is, of course, what does it even mean, instrument? Like, what's our goal here? And the most important thing you want to get out of instrumenting an application, I have that on this dashboard here. Maybe I should make it a bit smaller. Maybe you have seen dashboards like this. What you see here are what we call red metrics. So red is the short for request rate, error rate, and duration, right? That's the first characters. And this is basically the best practice. When you want to monitor an HTTP service, then the red metrics, the request rate, error rate, and duration, these are the most important metrics that you need to have. So the request rate, so we see here that our name generator gets about 0.8 requests per second. So that indicates the current load on the system, right? Error rate is, of course, how many of these fail. In that case, it's 0%. So my name generator always succeeds with HTTP 200. And then duration is how long it takes. And we see here that my 95th percentile is around 800 milliseconds. So 95% of the calls are responded faster than 95 milliseconds, right? And this is the most important thing. So if you don't have that, please fix that first before you look into other things. But of course, once you have that up and running and reliable, there are other signals as well, like tracing, logs, profiles, and so forth. And I will touch these later in the talk as well. So now we have seen the demo. We have an understanding what our goal is. And now the first technology that I want to show you is Java agent. And I think the best way to learn something is to just try and do it. And so I actually have a small example of how to write a Java agent. So because I'm just fascinated how easy this is. And this is easy because there is a library named ByteBuddy. So here in my package. And ByteBuddy is a library that makes writing Java agents pretty straightforward. So a Java agent is basically something that has a pre-main method. So pre-main is called before the main method of your application, actually, right? And this is what you see here is a little bit of ByteBuddy API. And what I'm saying here is, please Java agents can modify bytecode, right? So they can rewrite methods, they can rewrite classes, and so forth, right? And in Java, we have this standard named servlet. And basically everything that does HTTP in Java somehow behind the scenes uses the servlet API. So I have a Spring Boot application, for example, and Spring Boot, of course, uses the servlet API under the hood. And what I'm saying here, every class that implements the servlet interface should be instrumented, and specifically the method named service within that class. And then there is a second thing here, telling ByteBuddy what to do with these classes. So on method enter, when I enter the service method, I do basically nothing. I just take a timestamp so that I can later find the duration. And on method exit, when I am done with my service method, I just grab some things like the HTTP method, HTTP path, status, and then I calculate the duration, current timestamp minus the one that was returned by this enter method. And then in this case, I just print everything to the console, right? And that's it. That is the complete code of a working Java agent. So there's nothing more to it, right? So ByteBuddy really makes this easy and hides all the complexity. So what we can do now, we can go ahead and set an environment variable. So there's a magic environment variable named Java tool options that the JVM supports. And we provide it with a path to our Java agent here. And now, if we start our regular name generator service, it will start up as usual, but now the Java agent is attached, right? And now if we just do some REST calls, like, say here for an English boy, for example, right? We still get names in return. Oh, that's my mouse here. So we still get names in return, but what we see, like magically, the Java agent was somehow attached and printed this fancy line here, right? And this works every single time, right? And I find this fascinating. I find this really cool that with just like 20 lines of Java code, you already get kind of all the information that you need to set up such a red dashboard. So it really makes it very accessible. So in the real world, of course, you don't write these agents yourself. There is an agent that already exists from the OpenTelemetry community. It's called the OpenTelemetry Java Instrumentation agent. You find it on GitHub. You download it. You probably run your applications in Docker. So you add it to your Docker container, set this Java tool options environment variable, and you're done. That's how you use OpenTelemetry for Java. Pretty cool. So now that we have seen Java, let's look a bit into the alternative, eBPF. And since I mentioned Beyla a couple of times, I want to just quickly start and tell you how these two projects relate. So Beyla is an eBPF-based instrumentation tool that we made at Grafana. It's available here in this GitHub Grafana Beyla repository. We have been developing this for about 2 years now. And a couple of months ago, we joined forces with others who want to contribute and donated it to the OpenTelemetry community. So the same code is now available upstream in the OpenTelemetry project, and most of the Grafana engineers that worked on Beyla now mostly work on the OpenTelemetry project, right? So I have a demo that still uses Beyla, but I could use the OpenTelemetry version and it's the same thing, right? Same features, no difference. So let's also show you a quick example. So we still have our service running, which is convenient. So with Beyla, when you download it, it's basically a single executable, right? So you just start it. Before you start it, you need to set some environment variables or write a configuration file. So the first thing is Beyla supports both OpenTelemetry metrics and Prometheus metrics and tracing, of course. So you need to configure what it should do. And for this quick demo, I'm just going to say, please expose Prometheus metrics on port 9400, right? So this is one. And the second thing is you need to tell Beyla which process to instrument. And what I know is that my name generator here is running on port 8081. So I'm going to set this environment variable here to tell Beyla, find whatever is running on port 8081 and instrument it, right? And now I run Beyla. I need my root password here because it needs the rights to install eBPF probes. So there's also like kernel capabilities to make this easier, but that's not needed for this demo. And now that Beyla is up and running, now we actually got the service instrumented twice. So if I run some requests, we still see that, you know, the Java agent is attached, right, doing its thing, but also Beyla is attached now, and it should expose Prometheus metrics. So let's check this. If I go to localhost port 9400/metrics, yay, here we go. A whole lot of metrics being exposed, right? So if we look at server request duration, for example, so this is a standard histogram defined in the OpenTelemetry standard. We see the HTTP method, we see the status code, we see the path, we see histograms with the timing information and so forth. And we could now set up a Prometheus scraper to read these metrics, store them in a Prometheus database, have our Grafana dashboards, and we are done as well, right? So, pretty cool. Let's get back to the slides. If you see that demo, I think it looks like eBPF is also very simple, like a Java agent, but it's not. The thing is, like, it's easy to use, right? It's just this single binary that you run and then it magically instruments stuff and so forth. But implementing eBPF probes is a lot harder than implementing a Java agent with ByteBuddy, right? So if you want a picture how eBPF works, so eBPF is basically a feature of the Linux kernel, which allows you to load probes into a secure sandbox in the Linux kernel, and then this probe can access memory parts, right? So it basically gives you a tiny peek hole in the Linux kernel where you can look at what things are going on. And if you look through that peek hole, you basically see the matrix, like you see raw memory, right? And you need to make sense of where are function calls, where are parameters, where do I even find things and so forth. So this is a lot harder than writing a Java agent. And if you look at just this simple dashboard, request rates, error rates, durations, like in Java, you have just seen like 20 lines of code and that more or less have it, right? That's good. If you just use eBPF probes and want to figure out what's going on, it's hard, right? So you have HTTP, which at least has like one connection per request. So a connection starts, is served, and then the connection terminates. So you still need to find out how to parse, you know, status code and so forth. But then you have keep alive, where the connection just keeps alive, and you need to find out where does something end and where does it stop. And then you have HTTP2, where you have multiple requests in parallel over the same connection, and HTTPS, which is encrypted. So you cannot read encrypted traffic by just looking at the kernel. So you need to look into the user space and grab the important information before it's being encrypted, so that you get things like the HTTP status code. And for encryption, most people use OpenSSL, which is good. You instrument this and you're good, but some don't. Java doesn't use OpenSSL and Go doesn't use OpenSSL, and so you need to instrument all these things as well, right? And coming to a state where you have these simple request rates, error rates, duration is a lot of work. This works now with Beyla. We did it. It's great, but it's by far not as simple as doing the same thing with a Java agent. So now, this was a quick overview of how Java agents look like and how eBPF looks like. And the rest of the talk, we are going to look at differences. So the first one is obvious, which is that Java agent is a JVM feature that only works on JVM applications, I guess, right? So in my demo, as you have seen, I also have a little node front end. And of course, there Java agent doesn't help, right? eBPF is a Linux kernel feature, and it works independent of the framework and programming language, right? You can have Go applications, Node, Python, Java, .NET. Like we are currently with these red metrics. I think there is no language or framework that we are aware of where this wouldn't work. Right? It really covers independent of the technology. You can always get your red metrics. This is obviously good, right? On the downside, red metrics is more or less it. The OpenTelemetry Java agent gives you more information, right? It gives you like information, what's happening inside your Spring framework, what's happening on your Hibernate layer, what's happening in your whatever enterprise Java beans and so forth. All of that we didn't implement in Beyla, right? So Beyla is more for the breadth. You cover everything and get decent red metrics. And Java Agent is more for the depth. It's only Java, but for Java it gives you more insights, right? So the second one, Kubernetes metadata. That is actually an interesting one, and I can show you. Let's run a query here in Grafana. So I have my Prometheus database where all the metrics are, and I'm going to look at the histogram count of the HTTP server request duration. Well, where is it? Here we go. So this is basically just counting how many requests are coming in. And I am, oh, that is not the server, that was the client. I wanted to show you the server side. Otherwise, we just see the Node.js front end. That's not so interesting. Here we go. So what I wanted to show you, that's basically just two lines, right? The line at the top is what's coming from the Java agent. The line at the bottom is what's coming from eBPF. And the difference is eBPF, so the Beyla tool also adds Kubernetes attributes. So you see that the name of the deployment here is actually front end, and the kind of deployment is, it's a deployment in that case, right? The node is actually the control plane where it's running, and the pod name is this one here, and so forth. With the Java agent, this information is missing, and the reason why it's missing is because technically I set up my demo wrong, because it's supposed to be used in a different way. So what you have, the Java agent just, provides metrics, traces, logs, but it does nothing with Kubernetes metadata. And the way this is supposed to work in OpenTelemetry, you have a man in the middle here, which is the OpenTelemetry collector. And so the agent sends all the signals to the OpenTelemetry collector. The collector talks to the Kubernetes API server, gets all the metadata, bundles it together, and then you store it in your monitoring framework. And because in my demo, I didn't set up an OpenTelemetry collector, I just push metrics directly to the backend, the metadata is missing, right? So with Beyla, this does not happen. Beyla has support for Kubernetes metadata built in, and so you get the full package out of the box, right? So you don't need to enrich anything. So, response time versus service time. This is my favorite. This is really, really unexpected. And what I'm going to do now to show you this, I have a little script that I can use to increase the load on my system here. Let's go to my directory here. Scripts, increase load. Okay, that should do the trick. And now let's look at the signals. So we go back to dashboards, and I made a dashboard that I called latency. And what you see here are latency numbers, of course. And the first graph here is from the front end's point of view. So the front end calls our Java backend service. And what this here shows is the response times that the front end actually gets. Like when it calls the backend service, how long did it take for the backend service to respond? And this used to be around 800 milliseconds the whole time. Now I ran the script at this point, and now we have more load on the systems, and now the response times go up to about 3.5 seconds, right? So, and it will remain at that level in the future. Now, I instrumented the Java backend twice with Beyla and with OpenTelemetry and eBPF with the Java agent, so that we can compare things. And with Beyla, you see what's expected, right? You have this whole 800 milliseconds thing going on. Then I ran the script, and then the latencies went up to 3.5 seconds. That's the same as the front end actually experiences. So that matches. With the Java agent, the line just remains at 800 milliseconds. You will, if you just use the Java agent and look at your red metrics, you will never see that this service has become slower. And that's actually interesting, why that happens. So how comes that the Java agent doesn't see this spike in latency? And the reason is, when I wrote this demo, I did something to make it like a little bit more easy to demonstrate. I set this property in my application property. So that says my Tomcat server should only have 10 threads. Otherwise, like with the default, it would also work, but then I would need a lot more traffic to show this, right? But now there are 10 threads in my Tomcat. And my increase, my script that increases the number of requests now started sending 40 requests in parallel, right? So what happens if you get 40 requests in parallel, but you only have 10 threads? The first 10 requests get served, and then the next one waits, right? It gets accepted, waits until a thread is available. Once a thread is available, it gets served as well, right? And so you have a queue of requests waiting until they're actually being processed. And now if you remember how a Java agent works, it hooks into the implementation of the service method, or maybe into the implementation of a Spring handler, or whatever they decided to implement. But these methods are only called once the request is actually served, right? When the request is still just waiting in accept state, and it's not even like handed over to a servlet or to Spring or something, then the instrumentation doesn't start yet, right? So with the Java agent approach, you miss all the queue times, right? You just get the actual service time that your methods take, but you miss times that are spent in queues before the methods are actually called. And that is why if you look like with eBPF on the kernel level, of course you get the complete picture, right? You get, this is when the accept of the TCP connection actually happened, and this is when it stopped, right? So that is accurate data. With the Java agent, it may happen that you only see, service time, but this is different from the actual response times that your client experience. All right, so what else do we have? HTTP path, that is also a nice one. So in my service, let's go to my code, how I implemented this service. I have, let's make it a bit larger. I have an HTTP path like this, right? Names and then 2 path parameters, language and gender, right? What you want to avoid if you have this kind of path parameters, you want to avoid something like this here that you should see in my front end, that like for each combination of path parameters, I see a different time series here, right? Maybe in this case, it's still okay because it's like 12 combinations or so. But imagine that's not a country, but maybe some unique ID or something, right? Then for each unique ID, you would create a new time series. And at some point, you would have so many time series that you overload your Prometheus server or whatever monitoring backend you have, and your monitoring will not work, right? So it's important, if you have path parameters, to come up with something like this, where you actually have just the parameters here and aggregate all the requests into, like, this is for this REST endpoint. So doing this is, of course, easy for the Java agent because it hooks directly into Java code, can see where these annotations are processed, and just gets the right thing. It's hard to do this with eBPF, and it doesn't work 100% of the time. What always works, Beyla has a feature where you can configure path mappings manually, but that's of course a lot of work, right? You need to look through your code, see what path templates you have, configure them, and so forth, so it's a lot of work. One thing that it has that is on by default is what we call the gibberish detector, which is in this GitHub repository here. And that is a thing, like it's actually kind of a machine learning thing. So if somebody calls a path like names and then maybe some unique identifier and then a word again, so it's a machine learning classifier that learns that these combination of characters look like an English word, and this combination of characters does not look like an English word, right? And so what we do when we see something like this, we take the stuff that doesn't look like English words and replace it with an asterisk, and then as path template, you get something like this, right? And that is kind of an okay default behavior because it already catches a lot of bad cases where you have like unique identifiers, some random garbage. At least you just see some stars and it doesn't overload your Prometheus server. But of course, it's also only heuristic, right? At some points, it might not see something. And especially in my case, when I have like actual country names here that look like English words. So of course, it's not replaced with a star, right? So there's one more thing that Beyla does, and this is actually really cool. I just learned this like a month ago. The JVM, do you know the command named jcommand? This one? So the JVM opens a local Linux socket where a tool like jcommand or also Beyla can, connect to the socket and send commands to the JVM, right? And one of the commands this thing can send, so you need the PID, which process to send it to. Let's send it to my name generator. There's my middle mouse button. Jesus. So this is the PID, and I'm going to send the command vm.symbol table, which will dump the symbol table. And what this will do, it connects to my JVM and dumps all the symbols that are loaded in the JVM, right? And now, of course, the path templates are also available as symbols. So if I search for a pattern like slash and these curly braces, because that's what you usually see in path patterns, you see, hey, one of the symbols is actually this. And this is coming from my annotation in my Spring application. And so one thing that Beyla does is it actually does the same thing as this jcommand here, just connecting to the JVM, loading all the symbols and guessing like, this looks like a path, so let's use this, right? Which is pretty neat. This is also why we see here in our demo in the Beyla instrumentation that it actually got the template and not like the real path. But as you can imagine, that's still something like a heuristic, right? I mean, maybe you define paths in a weird way and then it doesn't work, or maybe whatever, you have some lazy loading of paths and then when we dump the symbols, they are not available and whatnot. So it's definitely a bit like of a weak point of this eBPF approach. So what else? Tracing. Tracing is actually also a nice one. So maybe I should show you how a distributed trace looks like. So I enabled tracing here as well in my demo. I assume you have all seen traces before. So Tempo is an open source trace database that I'm using here. If we look at an example trace, it's all a bit zoomed in, right? Trace looks like this, right? So you see the behavior of your distributed application. You see a request is coming into the front end, does something internally, then a request is going out to my backend, and then my backend receives a request and so forth, right? And all of these spans have metadata, so you can look at it and learn whatever. This is the path template, and this is the HTTP status code and so forth, right? So tracing is awesome if you have a lot of microservices talking to each other and you want to understand, you know, the big picture, who's calling what and how do things fit together, then you use tracing. So what do you need to do to implement tracing? So there's an incoming request, and this incoming request might already belong to a trace. The way this works is that the incoming request will have a header named trace parent, and this trace parent header will have the trace ID, right? So that's how you learn when a request is coming in, if that already belongs to an existing trace context. And then, of course, your service might call other services in your microservices architecture, right? So if you have an outgoing call, you need to take that trace ID and also put it in a trace parent header there, so that the next service down the line also knows what trace this call belongs to. And these things, I mean, the Java agent can do them anyway. It can modify whatever bytecode, and so that's easy. But we can also do this with Beyla. We can parse the trace parent header, which is probably easy because we also parse other things. But we also found a way to inject the trace parent header, at least for HTTP. I think HTTPS doesn't work, but HTTP, that would also work. So you might think, if we can parse incoming headers and inject headers to outgoing requests, that we can do tracing, but we cannot, or at least not in general, because the problem is what happens if there are multiple requests coming in parallel, right? So you have a whole bunch of parallel requests coming in, and then at some point a whole bunch of requests going out, and now you need to know, okay, the trace ID from this request actually needs to go to that outgoing request, and like you need to correlate these. And this is really, really hard to do. We found a solution for that for some technologies. So for Go, usually like internally they use Go routines to schedule stuff, and we found how to instrument Go routines that works. We've made it work for Node.js, Nginx, and of course like synchronous frameworks that just have one thread per request. But if you look at like a modern reactive Java application, right? Reactive Java applications, you can imagine them a little bit like a washing machine or a tumbler, right? It's like something's coming in and then there's like tiny fragments of work items scheduled through different requests all the time. And if eventually some request goes out, it's really impossible with eBPF instrumentation to track what belongs to what. And so if you have a reactive Java application or .NET, tracing will be broken with Beyla. And then if you want tracing for these technologies, you have to use the Java agent. So 2 more or 3 before we come to conclusion. Logs is actually similar. So logs, then nobody really instruments or intercepts logs, right? Applications usually still log to the standard output and you kind of read logs from there and so forth. But what the Java agent does, maybe I should have put this at the top of the slide because that's the most important thing. So the Java agent, if a log line is written in the context of an HTTP request, then the Java agent puts the trace ID of this trace in the log context, and then you can include it in your log template. And then each log line will have the trace ID included. And then you can do things like you look at a trace where something failed with an HTTP 500 status, and then you search your log files and say, give me all the logs that were written in the context of this HTTP request, and then you kind of maybe find some exception messages and stuff like that. So that's really helpful, and that is also something that we cannot do with eBPF for the same reason why tracing is hard. At the time when somebody writes something to standard out or to a log file, it's really hard to see like what happened internally before, like which context does this come out of and so forth. So that is also something where like the Java agent is a lot better. Yeah, 2 small things. Impact on production service, that's kind of obvious. So if you want to apply the Java agent, you need to apply it at startup. So if you instrument an application, you have downtime. You need to stop your service, set this environment variable Java tool options, start your service again. So you will have a scheduled downtime for attaching your Java agent. And if there are some issues and you want to remove the Java agent, you also need to restart your application and unset the environment variable, right? Beyla attaches at runtime. You have seen this in the demo at the beginning of the talk, right? You just say, find this process, maybe by open port, by service name, by whatever, and it will just attach. And it's also low risk because if for some reason something goes wrong and that has an impact on your application, you can just terminate Beyla and then the Linux kernel will automatically remove all eBPF probes that were installed by Beyla. So the application will then be run unmodified as before and it's never restarted. And the last one that's maybe more forward-looking. So of course, with Beyla and also Java agent, like in all of OpenTelemetry, we continuously add support for more protocols. I mean, HTTP is pretty much covered, some SQL clients or something also, but recently we added like a MongoDB client and we are working on message queue clients and so forth. So more and more network protocols are being added. And with Beyla, you have this one place where you, when you add support for a protocol there, it's available across all technologies, right? So no matter, like if we have a SQL client instrumentation, it doesn't matter whether you actually access your SQL database through Node.js, through Python, through Java, whatever, it just works, right? It's this one place where you implement it. With Java agent and all the other like language-specific frameworks that you have in OpenTelemetry, the problem is that there might be a work group for SQL client metrics, for example, but then the Java SIG has to implement it, the Python SIG has to implement it, Node.js SIG, and so forth. And it takes ages until it's really consistently available everywhere, right? So like the speed of innovation, like how to make things available across the board, it's definitely a lot easier if you have to do this just with a single tool than if you have to do this with a zoo of different, agents for different programming languages. All right, so that was my walk through a couple of the differences. And I want to conclude with like a recommendation, or let's say at least a view of how like the current thinking of myself and also others at Grafana is like, how should you actually use things now, right? And the main idea is that it's not either or, right? It's not like you either use a Java agent or you use eBPF instrumentation. I think what is a much better approach is you use both. And so what I mean is, right, eBPF just gives you very reliable red metrics independent of the technology. You don't need to touch your application. It's just there, right? So if you have a platform like Kubernetes or some other platform, just install eBPF. Like if you install it on Kubernetes as a daemon set, the eBPF instrumentation will be available on each node in your Kubernetes cluster. And whatever you install there will have proper red metrics that you can rely on, right? And that is definitely worth something. That doesn't require engineering effort, that doesn't require environment variables or restarts, or even if somebody, whatever, comes and has some Rust application or some weird other framework, you always have like this baseline instrumentation that gives you the red metrics. And I think that should always be there. So just have Beyla on every node, use it for red metrics, and then you have this base coverage, the most important thing. And then, of course, there are technologies where Beyla doesn't work, like we've seen tracing of reactive Java applications, right? And then it's, of course, a good idea on top of that for your services that use Java to also use the Java agent. But that doesn't mean you have to remove Beyla. Just keep it running, right? I mean, then you have traces from the Java agent, maybe some additional JVM metrics, some logging tricks and more insights. And that's great. And you can use all of that, right? But still, one level lower, you still have these red metrics that are just your baseline and that are always there. And I think that's kind of the future where we are heading, right? To have this baseline instrumentation with eBPF and then technology-specific instrumentation with things like Java agent or equivalent agents for other languages. And in the Beyla team, we are already working on how to integrate Beyla instrumentation better with the Java agent. So if Beyla detects that you now attached a Java agent, that we use the same names, the same paths, and so forth, and we want to make this as smooth as possible. So basically, conclusion is, it's not either or. I think eBPF instrumentation should be an infrastructure feature that's just always there for every host. And then still, please apply your Java agent because it will give you deeper insights for the services that use the JVM. And this brings me to the end of my talk. Thanks for listening. If you have any questions, I think we have 1 minute left.